brief supplement to the lecture for class 4, and in this little mini lecture I'm going to go over the Prolog code I discussed in class, so we'll look at the code and we'll see it being used. So we developed in class and went through a little Prolog program to see what form of syllogism is being used. So a syllogism is either modus ponens, and the typical form of modus ponens is something like P1 implies P2, we know P1 and therefore P2, or it's modus tollens, and we know that P1 implies P2, we know not P2, and we can conclude not P1. And finally, there's a third form of syllogism which actually is incorrect. It's not proper reasoning. It's called abduction. And an example, and basically abduction means we've got P1 implies P2, we know P2, and that means P1. So for instance, an example of abduction which I gave in class is if it's raining, the streets are wet. The streets are wet, therefore it's raining. And that's not a proper form of reasoning because the streets could be wet for other reasons. So in the Prolog code, there's the predicate, check reasoning, and it's got check reasoning has two terms, two arguments, and that's why in my comment I've set it as arity 2. The first term is something called terms, which itself has 3 terms. And then the second term is the kind of syllogism it is, which we'll return. So if it's a modus ponens, we expect to see 3 terms with some proposition implies P1, P2, and P2, or where we've reversed the order of the first 2 terms because whether it's A implies B and A, or A and B implies A, the result is still a proper syllogism. Similarly, I've got 2 forms of modus tollens, so we've got something like implies AB, not B, therefore not A. An example of that would be in our rain example. If it's raining, the streets are wet. The streets are not wet, therefore it's not raining. And that's a proper syllogism in modus tollens. Notice that I've got these as single words because otherwise it wouldn't be a constant in Prolog, wouldn't be a proper Prolog term. And then finally, I've got abduction, and that pretty much works the same way. So that's the program, and now let's try it out. So I've brought up the Prolog interpreter, and let's load our program we just wrote. Okay, so let's try out and see if we can do a correct example of a modus ponens syllogism. So our predicate is called check reasoning, and we know the first term has got to be terms. So let's see. Let's say we know that Fluffy is a cat, and we know that if you're a cat, then you're hungry. And from that we can conclude that Fluffy is hungry. So let's see. So it would be hungry, Fluffy. And if that's all true, then we know we have, well, I don't know what mode we've got, so let's find out. And we ask Prolog to tell us what it finds, and sure enough, it is modus ponens, and X has been bound to fluffy. All right. What happens if we give it something that's incorrect? So let me copy up to here. And instead of Fluffy being hungry, let's say we try to conclude that Spike is hungry. All right, what kind of syllogism is this? Well, it's not any kind of syllogism. It's not true. Now, actually, this will work for any syllogism, even if we don't bind the terms. So, for instance, if I say check reasoning terms cat, whatever the cat is, implies cat hungry cat, and then that should imply that whatever this unnamed cat is in fact hungry. Let's see if there's a mode associated with that. Now, the fact is that I don't have a specific cat in mind, but no matter what the cat is, it still should be a valid syllogism. Let's see if that's true. Yes, modus ponens and cat isn't bound to anything. And you can try running this with modus tollens and abduction and play around a little bit. So that's what we did on the board, realized as an honest-to-goodness working Prolog program.